Alright guys, welcome to the acceleration notes. I'm going to kind of go through this a little bit quickly since this is going to be a recording and it's not kind of in class. So I'm going to go through them pretty quickly. If you have questions, let me know. Feel free to reach out. Or rewatch the video or kind of go through at your own pace. Okay. So I am going through this new software, so I don't know how to quite use it yet. So give me some grace on that. Okay, what is acceleration? Before we do acceleration, let's unpack what velocity is again. If we talk about velocity as, speed or how fast you're going with direction, we can then categorize acceleration as a change in speed or direction or both. So let's think about an example there. Say if I have a ball and it's not moving. Its initial velocity is, let's call it 0. And then after some time, it's now going to the right at 10 meters per second. Well, it has accelerated its position, or it has accelerated and changed its velocity. So it's gone from 0 meters per second to now going 10 meters per second to the right, which means it has changed its speed. Well, we denote this as acceleration towards the right as positive. Well, what about acceleration, let's say, of something slowing down? What if my ball was already going to the right at 10 meters per second and it now stops? Well, it has a negative acceleration. Our speed has changed, which means at some point we have acceleration, but it's accelerated in the negative direction because it's slowed down. So now let's take this and let's apply this, and I want you to pause the video once you try these out. What if my object has a velocity of 0 and then is now going to the left at 10 meters per second? Will that acceleration be positive or negative? And then the last example would be, what would the acceleration be, positive or negative, if our object was going, let's say, let me draw my ball here, 10 meters per second to the left, so let's get negative 10, and then our ball comes to a stop. Would that acceleration be positive or negative? So go ahead and pause the video, think about it, try it out. I'm going to dramatically drink my water. Okay. If our ball, for this third example right here, is speeding up to the left, then that means acceleration has to be negative. What about if the ball's already going left and it slows to a stop? Then that means acceleration is positive. So in the same way we looked at velocity, acceleration is also a vector. So we're going to call, to the right and up the positive y and the positive x. And to the left and down, we're going to call that negative x and negative y and negative x. Oops, sorry, I got those backwards. There we go. Okay, so now we've talked about what acceleration is. Now let's unpack this formula. So I'm going to go ahead and erase these all real quick. Can I get all of it? Nope. Let's try it one more time. There we go. Okay. So what about the units of acceleration? Well, we know velocity is meters per second, and time is also recorded in seconds. So that means the units for velocity would be meters per second, or what we often use is just meters per second squared. So when we do an example, let's say if we do homework, we use m/s to the caret 2 to represent acceleration in our homework. Okay, so when you're typing in your answers, you want to hit the Shift 6 key, and that'll give you that caret symbol. Okay. Let's try this out now. Let's look at acceleration in the terms of an actual question. So what I want you to do is go ahead and pause the video, try this out and ask yourself the question, is acceleration going to be positive or negative? What do you think? And then use the formula to try this out. See if you get there, okay? You pause the video. Okay. All right, so we're looking at the question here. Our object started from rest and then was now going 8 meters per second. So that means it has sped up to the right. It means my acceleration here should be a positive number. So if we do this right, we should get a positive number. Okay. Delta. What does delta mean? If you've never seen this Greek letter triangle called delta, it always means final minus initial. Always, always, always. I don't care if you're looking at temperature, you're looking at velocity, you're looking at even acceleration, even looking at displacement. It's always going to be final minus initial. So what's our final velocity here? And that's going to be 8 meters per second. What's our initial velocity? Well, our initial velocity is from rest. So if an object's at rest, we'll denote that as 0 meters per second. And our time interval is 0.5 seconds. Okay, so back here, we're going to plug in our numbers in. Delta V means final velocity minus initial velocity all over time. All we need to do is plug and chug and check it out. So we got 8 meters per second minus 0 meters per second all over 0.5 seconds. 8 minus 0 is still 8. Divided by 0.5 seconds, which gets us 16 meters per second squared. So if this was an answer on Schoology, for example, it would be 16 meters per second, caret 2. Is our answer positive? Yes. Does our answer make sense? Is our object speeding up towards the right? Yes. So everything here checks out. So let's go ahead and try this next question out, where we look at what about the object that started, let's fix that real quick. What about the object that started moving at 10 meters per second and then decreased to 0? And instead of 3.5, let's do 2.5 for the sake of easy math. Okay. So once you try this one on your own, ask yourself, is acceleration going to be positive or negative? And then try using the acceleration formula to find this. I'm going to go ahead and get started though. So what we're going to do is we're going to think about our object. Our object is going 10 meters per second towards the right because it's positive. And then after a while, our object is now going 0. It has slowed down in the right direction, which means my acceleration is going to be negative. So let's go ahead and unpack it. Acceleration equals delta V over time, which means velocity final minus velocity initial all over time. Our final velocity, what's that going to bring us out to? That's going to be 0 meters per second. Our initial velocity is going to be 10. And our time is going to be 2.5 seconds. Okay? Let's plug and chug away, and we'll almost call this done. Our final velocity is going to be 0 minus initial velocity, which is 10 meters per second, all divided by 2.5 seconds. There is where our negative appears from. So 0 minus 10 is negative 10 all over 2.5. Negative 10 divided by 2.5 is going to be negative 4 meters per second squared, or negative 4 meters per second caret 2 if this was a homework question. Okay? Does this make sense? Yes, our object was going to the right and slowed down. Okay. There's a video here when you go to the notes in Schoology about gravity and how gravity works. I'm just going to let you watch that video on your own, and you can just follow along here. What happens if we look at acceleration in the y direction? The thing about it is, when you look at acceleration in the x direction, there's nothing pushing or pulling just naturally. However, if we look at acceleration in the y direction, we have gravity. And the thing about gravity is gravity works constant, at least in this class, on planet Earth. And we're going to use that number as negative 9.8 meters per second squared. So why is it negative? Well, gravity works downwards and it causes things to speed up in the negative direction. So initially, when you're dropping something, your initial velocity might be 0 if you're dropping it. But after a while, your final velocity is going to be a negative number because it's falling downwards. Okay? So you're welcome to watch kind of those videos on your own. I'm going to skip past talking about Isaac Newton. Really cool dude, a little weird. But he's that kind of thought of be the father of gravity, or at least discovering it. So, if a bowling ball and a feather, we'll see if I can draw a better feather. Hey, it's not that bad. So a bowling ball and a feather both fall down if we ignore air friction. So no air friction. Which would hit the ground first? Well, actually, gravity, or acceleration due to gravity, is constant, regardless of what it is. Everything will fall towards the ground at the same rate. We use that as negative 9.8. So any of our questions that deal with something dropping or falling from a building, we're going to use negative 9.8 as gravity. Okay? Like I said, you can watch this video if you want to. Watch that video. This kind of unpacks a little bit more. I'm just going to walk through these last two examples, and we'll call this done. Okay? An apple falls towards the ground, hits Sir Isaac Newton after falling for 1.2 seconds. What was the final velocity of the apple? So let's try that out. Well, what do we know? We know, since this is a gravity question, since we're falling straight down, acceleration due to gravity is negative 9.8 meters per second squared. What else do we know? Our time is 1.2 seconds. And we also know something else, our initial velocity. So if you think about our apple chilling in the tree, before it falls, how fast is it going? Well, that's 0. Our initial velocity is 0. And then after 1.2 seconds, it now has some velocity that's going to be negative because it's going down. We can actually use the acceleration formula to find what that is. So acceleration due to gravity is going to be change in velocity over time. That's going to be velocity final minus velocity initial all over time. And acceleration due to gravity, let's go ahead and erase that real quick. We know what that is. That's negative 9.8 meters per second squared. Our final velocity we do not know. Our initial velocity is 0. And our time is 1.2 seconds. Okay. Cleaning up this a little bit, we get negative 9.8 meters per second squared equals velocity final over 1.2 seconds, which gives us a final answer velocity of negative 9.8 times 1.2, which is like 11.74. 9.8 times 1.2, 76. That 8 will get you. So negative 11.76 meters per second. So after 1.2 seconds, a ball falling, or an apple falling, will be negative 11.76 meters per second, ignoring air resistance. Okay, one last problem dealing with acceleration, and I want to see if you can try this one on your own. An unfortunate person falls off a building. How long does that person have before meeting their maker? Their final velocity is negative 150. So let's look at this. We know since it's a gravity question, albeit a little morbid of a gravity question, Our acceleration is still negative 9.8 meters per second squared. Our initial velocity, think about the person just starts to fall off the cliff, is going to be 0 meters per second. Our final velocity we're given is going to be negative 150, and we're looking for time. Plug and chug in our formula. Acceleration due to gravity, delta V over t, negative 9.8 meters per second squared equals final velocity minus initial velocity all over time. This one kind of trips students up as far as the math goes, so make sure we're following along with me when it comes to this. Final velocity is negative 150 meters per second minus 0, because initial velocity is 0, all over t. Some students have a hard time rearranging this to get t by itself. Well, the first thing we're going to do is notice that this 0 and minus 0 doesn't do anything, cancels out, gone. Multiply both sides by t. So what I get is negative 9.8 meters per second squared times t equals negative 150. Divide both sides by negative 9.8. We get time to be 15.3 something, I believe. We'll see. 150, negative 150 divided by 9.8. 15.3 rounded. So 15.3 seconds. Okay. So there we go, folks. We talked about acceleration, about what it is. It's a change in velocity or direction. We've done a couple of calculations dealing with acceleration in the x direction. We did a couple with on the y, dealing with gravity. There's one last thing I want to talk about, and that is how do you change direction but not speed? So what we're going to do is we're going to do a little side tangent over here. If I got a bird's eye view of, let's say, the interstate on-ramp, which tends to make this little loop-de-loop. Oh, let's try that a little bit better. Let's make this better. A little bit. One more time. There we go. Okay, let's say you are traveling in a car, mom and dad, or whoever else, and you are not buckled in a back seat. But mom and dad, or whoever's driving, is going a constant 50 miles per hour. If they go on this on-ramp and don't change their speed, the entire time, they're going to be going 50. They should slow down a little bit, but some people don't. What happens here? Well, since your speed doesn't change and your direction does, you're experiencing acceleration. Where are you accelerating? We're going to make an imaginary point right here. And we are accelerating inwards towards this point. That for this certain amount of time, you're always curving inwards towards that point. We call this centripetal acceleration. Now, when it comes to centripetal acceleration, it follows some different mathematical rules, but the cool part is we're actually going to head out to the gym at one point and have you guys throw each other around in a circle using some carts and some ropes, and you get to experience centripetal acceleration yourself. Okay? You guys are awesome. Stay awesome. If you have any questions, let me know. And I'll see you guys in class soon. Take care.